particularly liked by many people, but often tolerated mainly because its usefulness. Something to think, especially when we are trying to explain the scientific projects that do not a priority into useful. So what experiment has started? The complex structures in the universe are made by combining simple objects in different ways, as we know in case of periodic table, are apparently diverse phenomena are often different manifestations of the same underlying physics that we talk when we talk about the orbits of planets, or we can say apples falling from the tree. But almost everything is made of small objects that like to stick together, the particles and the forces between those particles. So every day, intuition is not necessarily a good guide. What we live in a quantum world, even if it is not obvious to us. So I will just tell you about the history of particle physics. Modern particle physics began in the early 20th century as an exploration into the structure of atom. The discovery of atomic quantum physics was developed to explain the structure of atom, and the binding of the nucleus couldn't understood by the physical laws known at that time. Based on the electromagnetism alone, one would expect the protons to repel each other. But in mid 30s, Yukawa proposed a new force which holds the nucleus together and which would eventually become known as strong nuclear force. And he speculated that this force was mediated by the new particle, and he called those particles as mesons. Then the search for fundamental particles. Also in 1930s, Fermi postulated the neutrino as an explanation for the observed energy spectrum of beta decay, and he proposed an effective theory of weak force. Separately, the positron and the muon were discovered by Anderson. Then the Yukawa's meson theory was also discovered in the form of pion in 47. But over the time, the focus of the field shifted from understanding the nucleus to the more fundamental particles and their interactions. And this particle physics became a distinct field from the nuclear physics. So throughout in 1950s and 1960s, a huge variety of additional particles was found in the scattering experiments, and this was referred to as particle 2. Are protons and neutrons fundamental? To escape the particle zoo, the next logical step was to investigate whether these patterns could be explained by postulating that all baryons and mesons they are made of other particles. What these particles were named as quarks. As far as we know, the quarks are point-like in geometry. They are not made up of scientists or the physicists, we can say, no suspect that quarks and electrons are fundamental. An elementary particle or a fundamental particle is a particle not known to have substructure. That is, it is not known to be made of smaller particles. If an elementary particle truly has no substructure, then it is one of the basic particles of the universe from which all the larger particles are made of. And the scale of the atom, as we know, an atom is a tiny, the nucleus is 10,000 times smaller than the atom. And the quarks and electrons, which we say are the fundamentals, are at least 10,000 times smaller than that of your this nucleus. So we do not know exactly how small quarks and electrons are. What they are definitely smaller than 10 raised power minus 18 meters, and they might literally be points, but we do not know. It is also possible that quarks and electrons are not fundamental after all. What will turn out to be made up of other particles which are more fundamental. What the researches are still going on. What, as we know, the quarks and leptons, they are fundamental. And fundamental blocks means here we can say we have two types of point-like consequence. One is your leptons and other is your quarks. So leptons, in leptons we take electrons, we take muons, and we take tau, tau. Whereas in quarks we take